And welcome back to our channel. Here in this series, as I told in the previous video, I will be solving 100 physics question. So this is part 2, another 10 questions. And here we go. Question 1. What is the physical quantity that measures the reluctance to change in rotational motion? The reluctance to change means that opposite the change of motion. So which quantity works to oppose the change in motion? So of course it's the inertia, the moment of inertia, because it's related to the mass, and mass opposite any change in motion. So question: a student measures the mass, length, height, width, and electrical conductivity of a metal block. Which of these quantities are needed to calculate the density of the metal? So as you know from previous years, the density is equal to the mass over the volume. So to calculate the density, we need to know the mass of the body, the mass of the object, and its volume. So which of these options is the correct one? So let's discuss each one. So mass, length, height, width, and electrical conductivity. So we don't need reality the electrical conductivity. So the first one is a wrong answer. What about the second one? Length, height, and width. We missed the mass here. There is no mass. So this is another wrong answer. What about the last one? Mass, length, and height. We still we still missing one dimension, which is the width. So the third option here in this case is the correct answer, because length, height, and width give us the volume by multiplying all of these dimensions together. Next question. If the distance separating an electron and proton is halved, halved meaning cut in two or divided by two, what happens to the magnitude of the electrostatic force between these two charges? So what will happen to the force between the charges if the distance is reduced to the half? So to solve this question, of course, you need to remember Coulomb's law, which is F equal K multiplied by Q1, Q2 over distance squared. So according to the given, the R is reduced to half, it's divided by 2. So because F and R are inversely proportional, so F will increase because F is up in the equation, but R is down. So there is an inverse proportion. So if R decrease, F will increase. So, but still notice here we have a square. So anything divided by 2, then it will be transformed to divide by 4 because of the square. So if R is divided by 4, then F will be multiplied by 4. So quadrupled, because quadrupled means multiplied by 4 is the correct answer. Force will be multiplied by 4. Next question. Three capacitors are connected in series as shown in the following picture. What is the net capacitance between points X and Y? So here we have three capacitors put in series. As you know, to calculate the total capacitance, you need to use this equation: 1 over C1 plus 1 over C2 plus 1 over C3. You find the same denominator, and then you should not forget the inverse of the C total, and then the answer is 11 microfarad, which is the last option. A 50 ohm resistor and unknown resistance R, a 120 volt source, and an ammeter are connected in a complete circuit. So that's the picture of the circuit. The ammeter reads 0.5 ampere. Question is, what is the equivalent resistance of the circuit? So as you see, Here both resistors are in parallel. So we need to apply, to find out the resistance, total resistance in this question, you need to apply Ohm's law. So which is V, the voltage, equal R total multiplied by the current. What's unknown here, what do we need to find this question, is R. So R is equal V over I. So it's 120 divided by 0.5, and R total is 240 ohms. If one of the questions they ask for to calculate the other resistance, the value of the other resistance, so it's easy also because these two resistance are put in series. So R total, which is already calculated, 240, is equal 50 plus R, the other resistance that we don't know. So by arranging the equation, R will be equal R total minus 50. So the answer is 190 if they ask for the value of R, the other resistance. Continue with question 6. A potential drop of 50 volts is measured across a 250 ohm resistor. So what's the power developed in the resistor? So we need to calculate the power across the resistor. So there is an equation that describes that situation from grade 12, chapter 5. The power across the resistor is equal delta V square over R. So it's 50 square over the resistance, and the answer is, sorry, here it's supposed to be 10 watt, 10 W, 10 watt. Question 7, another easy question. Which circuit has the largest equivalent resistance? So we need to calculate which circuit has the biggest value of resistance. So of course we need to look for circuits which are set in series, because we already know circuits in parallel have low resistance because of the inverse. You remember, every time we increase the resistance, because of the equation 1 over R, R equivalent in parallel circuits should be smaller. So we need to look for a circuit in series. So as we're comparing the first and the second one, we can obviously see that the value of this circuit has bit more values than the first one. So this circuit has more resistance. We continue the next question. In diagram shows a wave pattern as you see here. The question is, which of the following represents the movement of a particle traveling in this wave? So if imagine that we have a particle on that wave, how that particle will behave or how that particle will move. So I will remind you of that picture here. Here we have a particle on a wave. As you see, the particle is still on the same place, but it's moving up and down, up and down. So the answer for that question is, and that will be the motion of the particle. We continue with the question 9. We are approaching the end of this part. So the diagram shows the force required to pull a spring a given distance. So here we have the picture, the linear relationship between distance and force. A mass of 0.06 kilogram is attached to the spring at x equal to 0. If the spring was pulled 0.4 meter and then released at 0.4 meter, so we have 60 Newton. You should take note of that. So what speed, asking for V, what speed or S will the mass have in returning to its original position? So what's the speed at the original position of the spring? So the mass, the distance or the displacement from the middle are given. The question is to calculate the speed S or V. So we need first of all to apply Hooke's law by using this equation to calculate K. So we already know that F equal K multiplied by X. So K is equal F divided by X. F, according to the picture here, to the graph, is 60 Newton because the displacement is 0.4. So for 0.4 meter, the force is 60 Newton. So that's how we calculate the K, and that's the picture of the spring. So we attach a mass to the spring, of course, the spring will be extended, and the extension in this case is 0.4 meter. So, of course, when we release it, the spring will get back to its initial position. So we need to calculate the velocity of the spring at position 3 here. Okay, so using the law of conservation of energy, we already know that the energy in position 2 equal to the energy in position 3. So in position 2, all the energy is a potential energy. It's a stored energy. So it's half kx squared because it's a spring. So the energy of the spring is half kx squared equal the energy in position 3. The energy in position 3 is only a velocity. The form of energy is all converted from potential energy to kinetic energy, which is half mv squared. So you arrange the equation, and then v will be equal to square root of k x squared over m. So k is already calculated here. It's 150 multiplied by the extension, which is 0.4 square, divided by the mass, which is 0.06 kilogram. And the answer is 20 meters per second. Last question. You are doing a great job. So a water piston has two sides, as you see here. Side A, which has a square cross section of L equals 0.25 meter. And side B, this is the second side, of a circular cross section of radius R, which is 0.5 meter. What is the mass needed to be added to the square cross section to lift the mass M of 1000 kilogram on the circular cross section, knowing that the height is 1 meter? So we have a piston. We already put a mass M here, so we need to make a balance in that pistons by adding some mass on the other side, on the other hand. So what will be the mass that need to be added on this hand? So using the thermodynamic equation, okay, so you should know, because both levels have both sides are on the same level, so you can say that P1, the pressure on this side, is equal to the pressure on the other side. And you already know that the pressure is equal to the force divided by the area. So F1 over A1, that's concerning the first hand, equal F2 over A2 for the second hand. So we only replacing the force by mass multiplied by gravity. So for F1, we replace it by M1 multiplied by gravity over the area in that section. The area for that section is L square, side multiplied by the side, equal F2. Also, it's according to Newton's second law, the force is mass 2 multiplied by gravity over, because here it's circular, so the area in that side is pi r square. The same, you arrange the equation to find out that M1, the only unknown in this question, M1 is equal to M2 multiplied by gravity multiplied by L square over pi r square multiplied by G. And the answer is 80 kilogram. So for this part, thanks for watching and stay tuned for part 3.